7.2, we're going to do the first two examples that I have here in the first video. We'll do this third one and the next one. For the first one here, we have to find the p-value for a right tail test with a test statistic of z equals 1.24. Decide whether to reject the null hypothesis if the level of significance is alpha equals 0.10. So first of all here, I'm going to sketch a normal curve like we've been doing. And if we have z equals 1.24, remember if it's positive, then it's to the right of the mean, which is in the center part there, which means that this area in here, since it's a right tail test, is going to be the area that we're looking for our p-value. And this value here is 1.24. So to find this, just like we did before whenever we're dealing with our normal distribution table, we look up 1.24. So if we do that, we get 0.8925. But since we're looking at the area to the right instead of to the left, remember we have to do 1 minus that. So just like you had in the last unit, if it's to the right instead of to the left in the normal distribution table, do 1 minus that area. So then you get 0.1075. And since it's a right tail test, it's just equal to that value for the p-value. So this here represents your p-value. Then if you look in the book there, if your p-value is less than alpha, then you reject the null hypothesis. But in this case, if you're looking at this p-value is greater than our alpha. So since it's greater here, that means that we fail to reject the null hypothesis. So here we fail to reject, and then remember to abbreviate the null hypothesis. We can write that as h sub 0. Remember that is the null hypothesis one. Null means 0 for that subscript. So that would be just the basics there in terms of deciding whether to reject it or not using the p-value. This next one we're going to go through some more specifics here with a word problem. So in this case it says one of your friends claims that the average age of students at your school is 21 years old. You believe this is incorrect, so you randomly select 32 students from your school and ask them their age. You find that the average age is 20 years old, with a standard deviation of 1 year. And in this case, whenever I was working it out, once again, this one didn't work out real well with the standard deviation of 1 year. So let's change that here to a standard deviation of 3 years. It'll make our numbers a little bit easier to work with here. So make sure to edit that in your notes. And then we want to figure out, is there enough evidence to support your claim at an alpha equals 0.05 level? And we want to use the p-value test to test this claim here. So first of all, for these types of problems, remember to write out what the null and the alternative hypothesis are. So remember h sub 0 is the null, HA is the alternative, just like we went over in the first section. So in this case here, the claim here, so here we have 21 years old is what we're testing here. So we're looking to see if it is or is not equal to that. So remember, in general, for the null, that always includes the equal to part. So you either have equal to, like we do in this case, greater than or equal to, or less than or equal to. If it doesn't have the equal to part, or if it's not equal to, then you have the alternative hypothesis that you're working with. And in this case, it says that we're testing your claim. So in this case, it says you're testing your claim. Your claim is that it's incorrect. If it had said your friend's claim, then that would have been the null hypothesis. In this case, it says if there's enough evidence to support your claim in this case. So you do want to make sure you're looking at that as well of whose claim you're looking at in general. If it doesn't specify whose claim, then you'll go with whoever is making the original claim. So, whenever we're doing this, first of all, we need to determine what type of test this is. Remember, to determine what test it is, if it's a one-tail or two-tail test, you look at the alternative hypothesis. In this case, the alternative hypothesis is a not equal to case. So that means it's a two-tail test. That'll make a difference in terms of doing your calculations here. And then we want to go through and find our test statistic. So remember example 1, it already gave us the test statistic. In this one, we have to calculate it. It's finding that z-score. So here we have to do our value minus our population mean value all over our standard error. So not the standard deviation, standard error, which is your 3 over that square root of 32, the sample size. So remember, we also went through that formula in the first section in terms of going through and doing that stuff. But this general formula here, once again, was doing that value minus the population mean over your standard error, which is your standard deviation over the square root of n. If you calculate that correctly here, if you need to, do the top first and then the bottom, and then divide the two answers. Make sure to always do the top divide by the bottom though. If you do it correctly here, you should get negative 1.89 for your test statistic for your z-score. Also keep in mind that this stuff, there are guidelines in terms of doing these types of problems on page 373 in your book. And throughout this chapter, there's guidelines for each of these types of situations. So here, if we're doing our curve here, we have a two-tail test. So that means our p-value is split between both ends. So even though our test statistic is only on the left side, we still have to calculate the area on the right end of this as well to include as part of our p-value. So here, if you look in the normal distribution, if you look up this area here for less than negative 1.89, you'll get 0.0294. So 0.0294 is what you should get if you're looking that up in your normal distribution table. Which, remember, the graph is symmetric, so that means that this other end really is a 1.89. And since it's symmetric here, this one is also 0.0294. So because a normal distribution curve is symmetric and it's a two-tail test, we have to include both ends for calculating the p-value. So what that means here is that our p, or our p-value, we use p in the book for the p-value, would be equal to 0.0588 after you add together both of those areas. Or you can do 2 times that 0.0294 to get that value as well for your p-value. Since you have both ends, you have to include both of those to calculate the p-value, even though the test statistic is just on the left side. So that's where it's critical to know what type of test you have first before you're going through and doing this. And in this case, this is greater than that alpha level of that 0.05. So remember, if your p-value is greater than your alpha, that means that we fail to reject. So just like an example one here, we fail to reject our null hypothesis. And then in general for these, whenever you're trying to test the claim, you should also have your interpretation here. So in this case, if you fail to reject H0, just get in the habit of once you state that conclusion, also explain what this means. So this means that you do not have enough evidence to support your claim, that the population mean does not equal 21. And that is at that 0.05 level. Because it's not always going to be the case that you're going to state that as your conclusion. Because for instance, if your alpha was 0.1 instead, if it's 0.10 in this case, then you would reject the null hypothesis because then your p-value would be less than 0.1. So it does make a difference what your alpha level is as well here. That's what that 0.05 represented. So if your p-value is greater than your alpha, then you fail to reject at that level. If your p-value is less than it, then you do reject the null hypothesis. Then of course your conclusion has to do with your claim, or whatever claim it was that you're testing in that problem.